In this lesson, 3.1b, we'll be using the distributive property to solve equations. So that is the first part of our acronym, SCAM. It is to use distribute and then combine like terms. We're not going to combine like terms, we're just going to distribute. We're going to combine that skill together in the next lesson. Then we're going to collect variables to one side. We're not going to have to do that. We will have to add or subtract the constant term away and then multiply or divide by the coefficient. So let's take a look at our first example. Okay, here we see 75 equals 5 times negative 5 minus 5a. So that means this 5, it means there are 5 negative 5's minus 5a. So we're going to distribute that instead of writing them all out. So that is 5 times negative 5. Well, we know that's negative 25. And then here we have 5 times negative 5a, which is negative 25a. Then we bring down the rest of our equation, and we move on to the next problem, or the next step. So here is my variable, okay? And then this is the constant term. This is a variable term, constant term. So we need to do the opposite of the constant term, which is positive 25 to both sides. And we get 100. 100 equals negative 25a. And now, to finish the problem, we take the coefficient, which is negative 25. Here's my variable term. It has a coefficient of negative 25. And we're going to divide that to both sides. Okay, and 100 divided by 25 is 4, make it negative, and then we get our answer for a. And then we rewrite it as a equals negative 4. Okay, so that was our first example. Now let's try our next example. Similar, we have our constant over here. It's equal to this coefficient of the parentheses that we got to clear. So we're going to distribute. Okay. So negative 5 times negative 1, negative times negative is a positive 5. Negative 5 times negative 4x equals positive 20x. All right, now we got to solve, and then we bring down the rest of our equation, 85. So here's my variable term over here. So I got to get rid of this. So I have minus 5. That's the opposite of 5 is negative 5 to both sides. 85 minus 5 is 80. And that equals 20x. All right, and now we have to divide by 20. Okay, the zeros cancel, and 8 divided by 2 is 4. So again, x equals 4, so we write it like this. Even though we have 4 equals x, we can rewrite it as x equals 4. All right, let's take a look at our third example. Okay, now we see the sides have changed and our distribution is over on the left side. That doesn't matter. It's still the same process. We're going to take our outside part, negative 3, and distribute it to each thing on the inside. So negative 3 times negative 3b is positive 9b. Negative 3 times negative 4 is positive 12 equals 57. The next step, here's our variable term, so we're going to minus 12. Okay, so those eliminate, and I get 9b equals 7 minus 2 is 5, 5 minus 1 is 4, and now we have to solve. So I'm going to divide by 9, divide by 9. Okay, and I get b equals 5. This time I don't have to rewrite it because the variable is on the correct side of the equation. All right, what happens when we have a fraction? Okay, and I'm actually going to show you two different ways. All right, the first way requires distribution. Okay, so let's try that. We're going to take the whole 5 over 9 and we're going to multiply it to each part. Okay, and we need to be careful with this, so we're going to write it out. So I'm going to have 5 over 9 times 9. That's the first part. We're going to put a 1 underneath this. 5 times 9 is 45 divided by 9. Okay, well, that is 5. And I could see that easily right here because the 9 would cancel the 9 right there, leaving me with 5. So 5/9 times 9 is 5, and then put the variable on there. And now we're going to do 5/9 times 27. And again, I'm going to put the 1 underneath it. Okay, and then we're going to cancel. 9 goes into 27 3 times, and then 5 times 3 is 15. And it's going to be negative, because this was a negative 27. And then equals 20. All right, so now it just turns into a basic solve the equation. We add the constant term away, so we add 15. I get 5x equals 35, divide by 5. Okay, and let's make a little more room. And then so we get x equals 7. All right, so is there another way we could have performed this problem? Absolutely. Let me show that to you. Okay, we're going to erase all of my work here. I'm doing it so I just have more room. Okay, the other way is I look, and the only thing I have over here is a coefficient of a expression. If there is nothing else on this side, and it's just a parentheses and a number outside, I can actually do the reciprocal of 5/9, which is 9 over 5. Put it up there, move it down there. And then I do that to do the same thing over on this side. So what's going to happen is the 9 cancels out that, 5 cancels out that, leaving me with 9x minus 27 equals, and now we do the same thing with a fraction. I know that 5 can go into 20 4 times, and 4 times 9 is 36. All right, now we just solve the equation. It's not the exact same setup, but it's going to give us the same answer. So I'm going to add 27 to both sides. Okay, so we get 9x. That eliminates. 6 plus 7 is 13. Carry the 1. 1 plus 3 plus 2 is 6. And then I get 9x equals 63. So I divide by 9, and x equals 7. Same answer, different work. Okay, but this only works if this is the only thing on this side. If there was a plus 5 or something like that, then I would need to distribute. All right.